at arithmetic sequences. Now, these are the really simple sequences that have just a common difference between them, okay? So at IB level, we can look at these in a bit more detail and answer some quite involved questions on them. So what we need to first of all just understand is what an arithmetic sequence is. The most simple ones are things like 3, 6, 9, 12, 15. Okay, obviously the 3 times table, it can go on. And the common difference here that makes it an arithmetic sequence is it going up by a common difference of 3. Okay, we might have other ones like this, 3, 5, 7, 9, 11, not your standard times table, but here we've got d equals 2. Okay, so both of those are called arithmetic sequences because their term-to-term rule is just to plus, or we could even have subtract as well. Okay, now deriving the formula for the nth term. So in this, I'm just going to show you where the formula for the nth term comes from. So we could have 1, 2, 3, 4, 5 terms, let's say. Now, in IB, we have to be used to the notation. We have to get used to the notation that's actually used for each term. So the first term is U1, the second term U2, the third term U3, the fourth term U4, and you've guessed it, the fifth term U5. Okay, we can go up to however many terms there are. Let's call that n. So the last term will be UN. Okay, and what happens in an arithmetic sequence, as we've just seen, is that each time to go from one term to the next, we just add on a common difference. So we call this D. Okay, so far so good. This is what's happening. All right. Now, what we also need to then think about to come up with this formula for the nth term is to write each of these terms in terms of U1 and D. Okay, so here we've got first of all U1, and then to get to U2 is just U1 plus D. Okay, so this is just this. And U3, the third term, is U1 plus 2 Ds. Okay, so we can say that. So it's U1 plus 2 lots of D. And if we wanted to get to the fourth term, that's just U1 plus 3 lots of D. Okay, so U1 plus 3D. And follow the pattern. Yep, okay, so U5 is the same as U1 plus 4 lots of the common difference. Okay, now what we need to think about now is the pattern that's occurring here. Okay, so we've got the first term, we've got the second term, we've got the third term, the fourth term, and the fifth term. Can we come up with some sort of general formula for the nth term, for any term of the sequence? What happens? Well, each one of these terms starts with U1. Okay, and then what happens is the n, which is the term number, which is the numbers on the top, here in this case 1, then 2, then 3, then 4, then 5, the number of common differences that we're adding on is actually 1 less than the term number, isn't it? So for the second term, we add on 1 common difference. For the third term, it's 2 common differences. For the fourth term, it's 3 common differences, and so on. So I hope you can see that we just add on n minus 1 lots of the common difference. Okay, it's just some brackets there. Okay, so in general, what we can say is that any term of a sequence is equal to the first term plus the term number of the sequence, subtract 1, multiplied by the common difference, okay? And that is actually the nth term for an arithmetic sequence, okay? Now, it's nice to understand where that's come from, to understand it, okay? But really, we don't have to remember it because it's actually in the IB formula booklet. So here it is from the formula booklet right there. So you've got that in the exam, okay? But it is useful to actually understand it so that you've got an understanding of it. It makes it easier to unpick questions and answer them. Okay, so let's have a look at this question here, for instance. So in this question, write down the term indicated in square brackets for each of these arithmetic sequences. Okay, so let's, first of all, in part A, let's write down the things that we know from this formula already. So we've got U1 plus n minus 1 D. Okay, right, so first of all, we want to find what the 10th term is. So we don't know what the 10th term is at the moment, okay, but we're trying to find it out. We do know the first term is number 1, and we do know that we've got n equals 10, looking at 10 terms, and we know the common difference. We can just look at the sequence and see it. The common difference is equal to 4, okay? So from all of that information, we can then put those things in. So U10 is going to be equal to U1 plus n minus 10 minus 1 times D. So U10 is going to be equal to 1, which is the first term, plus 9 lots of the common difference, which is 4. Okay, so it's going to be equal to 1 plus 9 times 4 is 36. So the 10th term of that sequence, if we counted up to the 10th term, would be 37. Okay, so once you get good at this, it's just a quick way of working these terms out. The 30th term, obviously I don't want to count up, by 2 30 times. It's very time consuming, very tedious. So what I'm trying to find is the 30th term. We don't know what it is, but we're going to find it out. The first term is number 7. There are 30 terms, and we have a common difference of 2. Okay, so putting all that together, the 30th term is going to be u1 plus 30 minus 1 times a common difference. So the 30th term is going to be number 7 plus 29 times by 2, which is equal to 7 plus 58, which equals 65. So much, much quicker than counting up by 2 30 times or 29 times. That's quite boring. Okay, so there we go. So we've answered those 2 questions. Let's look at a different type of question next. Consider the sequence. So here automatically we can see that u1 equals 3. The common difference looks like it's 9. Show that the sequence is arithmetic. Well, we've just shown that the common difference equals 9. Okay, as long as we can just say that, that's fine. And that's what defines an arithmetic sequence, if it has a common difference. Find the formula for the general term. Sorry, there should be a small n there. So un is equal to u1 plus n minus 1 d. Okay, so how many of these things do we know? Well, the formula for the general term, so this is what it is. u1 is 3, and then we don't know how many terms there are actually, not necessarily 5, it might just keep going. So n minus 1, and then the common difference is 9. Okay, now I could leave it like that, but it's a little bit messy with the brackets. So what I'd probably end up doing is just think of it as being a bit like this, put the 9 to the front instead, and then just expand the bracket there. So it's 3 plus 9n minus 9, or the nth term is, in its simplest form, 9n minus 6. Okay, now part C, that makes it really easy now to find things like the 75th term, because n is 75. So all we have to do is substitute in 75 as n, and 9 times 75 subtract 6 is equal to, I did work it out earlier, is 669. Okay, so 669, excellent. Okay, now part D is a common question. Are these members of the sequence? They are members of the sequence if you can have a value of n that when you multiply by 9 and subtract 6 gives you that particular value. So, imagine if you put n equals 2 in, that's 18, subtract 6, that gives us the second term, which is 12, okay, for instance. So let's test whether 147 fits this. Is there an integer value of n that fits this? Let's have a look. Let's rearrange it. Let's add 6 to both sides. First of all, so we get 153 equals 9n. And so n is 153 over 9 is 153 divisible by 9. And I've got a feeling it was, yes, it is. It's n equals 17. So this is actually the 17th term. So yes, it's the 17th term. It's U17. Now I've run out of room here, so I've been making a little window up here to work this one out. 2, 3, 4. Let's check if this is part of the sequence. What is it? 9n minus 6. Okay, so add 6 to both sides again. 240 equals 9n. N is 240 over 9. Is that, doesn't look like it. No. Okay, so it's 26.6. What that's telling us is that actually 234 lies between the 26th and the 27th terms of the sequence, but it's not actually a term of the sequence, okay, because it's not an integer value of, it's not a term number. It's the 26 and 2/3 term. It doesn't really exist, okay, it's just a abstract thing, okay, so it's not halfway, it's between 2 terms, okay, so that's not, so no, it's not a term of the sequence, no. Okay, hope that's clear. And the final one, actually, I think it's the final one, yes. The final type of question is this one. I love these questions. It all relies again on this, your understanding of this. Okay, so what we're going to do is think about I'm going to go backwards actually and do U8 first and show you this. So U8 would be U1 plus 8 minus 1 D. Okay, and we know that it tells us it's equal to 63. Now let's just simplify this bit here. So yeah, so u1 plus 7d is equal to 63. Okay, and if we take the information about the fourth term, u4, that's u1 plus 4 minus 1d if we are using this. Okay, we just put n equals 4 in, and we're told that that's equal to 31. So u1 plus 3d is equal to 31. Okay, now look what we've got. We've got two equations that have the same unknowns in them. So we're actually going to solve those simultaneously. I hope you've already guessed that. So if I write one above the other, usually the one with the bigger values in above the smaller valued one, and your instincts will hopefully take over here. We've got the same coefficient of u1, which is 1. So if we just subtract here, u1 subtract u1 is 0. 7d subtract 3d is 4d. And then here we've got 32 when we do 63 subtract 31. So we can find the common difference to be 8. 32 divided by 4 is 8. Okay. Now, we're not really it's detective work at the moment. We haven't worked out the general term yet, but we're getting there. The general term is u1 plus n minus 1d. So we've worked out one of the unknowns. We now know that this is 8. Okay, so let's put that in a different colour so it shows up. This is 8. The other thing that we want to know probably then is the u1. And we can find that. If we know that d equals 8, I can maybe just slot that back into here. Okay, so u1, substitute it back in. u1 plus 3 times 8 therefore is 31. So u1 plus 24 equals 31. And now if I do u1 is 31 minus 24, I find that u1 is equal to 7. Okay, so I've found that 7. So we're almost there. Let's just put those values into here then and say that un is equal to 7 plus n minus 1 times by 8. If we put the 8 to the front of the brackets again, just simplify it. This is going to give us the nth term. So n minus 1. So un, nth term, is 7 plus 8n minus 8. Or un, if I simplify it, is 8n minus 1. That's right, isn't it? Okay, 7 subtract 8 is minus 1. And that is the final answer. Okay, so randomly it's ended up there, but there we go. Okay, all right, so hopefully that is nice and clear. That was a trickier one at the end there. Okay.